Hey everyone, good morning. I am Priyanshu Agarwal and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is set matrix zeros. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an m cross n integer matrix, and if an element is 0, set its entire row and column to zeros, and you must do it in place. In place means you need to change the given input data and you don't need to use separate space for the output data. Okay, so you have been given a m cross n matrix and you need to set its entire row and column to 0 if an element is 0. Let's see in this example, this element is 0. So we will set this entire row and column to zeros. Okay. See in this example, this element is 0 and this element is 0. So we will set this entire row and column to 0 and this column and this row to 0. So this will be your final output with these elements as 0 and the rest of the elements as the input data. Okay. So one very basic brute force approach which comes to our mind is that we will start iterating in all the elements in this matrix. Let's say, is this 0? No. Okay. This 0? No. This? No. This? No. This? No. Oh, we got a 0. Okay, then what I will do? I will simply update this and this row and this complete column to zeros. Okay, so let's update it to 0, 0, 0 and 0, 0, right? This row and this column. Okay, now this is 0. Yes, so let's update this complete row and complete column to 0. Okay, the 0, 0, this is already 0. Okay, now again, is this 0? Yeah, this is 0. So what will I will do? I will update this complete column to 0 and this complete row to 0. But initially the only 3 zeros were there, right? And if we keep updating the zeros, this was not 0, this was supposed to be 1 in the initial input data, but we changed it to 0 because of this 0, and now this 0 is changing all other ones. So this way not going to work, right? If we keep on updating with 0 while iterating on this matrix. Okay, so what we can do, instead of updating them with 0, we can update them with -1. Okay, so if we encounter a 0, then what we will do? We will simply update this entire row and column to -1. Okay, let's update it -1, -1, -1, -1 and -1. Cool. Now don't update the zeros with -1, because if you will update the zeros with -1, then you will not able to update this entire row and column to -1. That's why if it is a 1 only, then update it to -1. Okay, now again you encountered a 0, update it to -1. These all are -1 already. Now this is -1, escape, this is 1, escape, -1, escape. Oh, again 0, update this to -1, this to -1, this already -1, this already -1. Okay, so now rest are 1s. So now in the second iteration, what we can do, we can simply update all these -1 values to 0. So what we will get? We will get something like this. So this is 1, this is -1, which we updated to 0, 1, -1, updated to 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1. So initially we were having these 3 zeros, right? So what we will do, we should be having all these rows and columns to zeros, right, which were intersecting these zeros, right? And yeah, see, we are having only these intersections as zeros and rest are 1, right? Okay, so what could be the pseudocode for this? So let's say you will start iterating in the rows and then in the columns, and then if matrix of ij is equals to 0, then what you will do? And then you will simply update that row to -1 and that column to -1, right? This function will update the row to -1 and this will update the column to -1. And then you will do one more iteration in the matrix to update the values to back 0. If matrix of ij is equals to -1, then what you will do, you will simply update it to 0, right? Okay, so what will be the time and space complexity for this? So this will take n, this will take m, and these are nested loops, so it will be n cross m. So time complexity will be n cross m, and then it will take n, and then it will take m, right? So this will be n plus m, and this is inside this n cross m, this is inside this loop, so it will overall become n cross m into n plus m plus this complexity of n cross m, again updating back to zeros because of n cross m. So as you can see that this is the overall of n cube complexity, right? Something like n cube. So obviously in the interviews, interviewer will not be happy with this n cube complexity. So this is the brute force approach with n cube complexity. But obviously in the interviews, interviewer will not be happy with this n cube complexity, so he will ask you to optimize this complexity. Okay, so let's see if we can do this in a better time complexity. Okay, so what we were doing, we were iterating on this matrix, and then if we encounter a 0, then we were going back to again update the matrix with -1 values. So does it matter if if a row or column has 1 0 or more than 1 0? If it have 1 0, then obviously this complete row and column will be 0. If it has 2 0, then still this complete row and column will be 0, right? So it doesn't matter whether a row or column is having 1 or more than 1 zeros. So can we keep track that whether if a row or a column has a 0, then we will keep track of that row and column, and then again iterate back to update the rows and columns to zeros. Okay, so let's see. So what we can do, we can create two vectors to keep the track of rows and columns, right? So it will keep this will be of size n and this will be of size m, right? N cross m matrix. Okay, so we will keep on iterating on this matrix. Is this a 0? No. This a 0? No. This? No, no, no. Yeah, we encountered a 0. So obviously this complete row and this complete column should be 0. So we will mark it as 1. Initially this is initialized with zeros. Cool. Now again we encountered a 0. We will update it to 1. It is already 1. 1, 1, 1. Oh, we encountered a 0 again. So it is already 1. We will update it to 1. Okay, now 1, 1, 1, 1, 1. Yeah. So we have done one iteration of n cross m in this matrix and kept the track of the zeros in these vectors. And now what we will do, we will again iterate back in this matrix and we check either this is 1 or this is 1. Then we will make that element to 0. Otherwise, not. Obviously, if this is not 1, if this is not 1, then obviously that row or column doesn't have any 0. So we will not make that element to 0. Because if this is 1, then either this or this should be 0. If this is 1, then either this or this should be 0. Only then we can make it to 0. If none of these elements is 1, then we will not make it to 0. Okay. Okay, now at this index, is this 1? Yes. So we will make it to 0. Is this 1? Yeah, make it to 0. Is this 1? No. Is this? No. Okay, is this 1? Okay, make it to 0. If this is 1, make it to 0. Make it to 0. Okay. This is 1, make it to 0. 0, 0. This is 1. No. This? No. Leave it. This is 1. Yes, make it to 0. This is 1. Yes, make it to 0. This one? No. This one? No. Leave it. Okay. So see, initially we were having these 3 zeros, right? We were having these 3 zeros. So we should be having by the end this and this complete indices as zeros. So yeah, we are having these indices as 0 and the rest as 1. Okay, so what we have done in this approach is that we started iterating in our matrix and check if that is a 0. If yes, then what we have done, we have updated our row of I to 1 and column of j to 1, right? Let's say this is a row vector and this is a column vector. We have updated it. Now again in the next iteration, we started iterating again in our matrix and check if row of I is equals to 1 or column of ij is equals to 1, then we will simply update our matrix of ij to 0, right? Okay, so let's see its code as well. So we started iterating in our matrix and check if it is a 0, then we will simply update the row of I to 1 and column of j to 1, and then if row of I is equals to 1 or column of j equals to 1, it means either row or column has a 0, so we will update that element to 0. So what will be the time and space complexity for this? Time complexity will be n cross m and n cross m, so it will be 2 into n cross m, and space complexity will be big O of n plus big O of m, right? As we are using these two vectors for keeping track of the zeros. Okay, so obviously we can't reduce the time complexity below n cross m, because this is an n cross m matrix, and anyways we will need to iterate on all these elements, so we can't reduce the time complexity. Now the question comes on the space complexity. We can't reduce the time complexity, so the interviewer will not be happy with this space complexity of big O of n plus m, so he will ask you to reduce this space complexity if you can reduce this space complexity of n plus m. Okay, so let's see if we can do something with the space complexity. So in the better approach, what we were doing, we were keeping track of the zeros with the help of these two vectors, right? Okay, but instead of creating those two separate vectors, can we consider this first column of the matrix and first row of the matrix as those vectors? Okay, let's say yes, if we can consider, but see, this index is overlapping, so how we will be able to consider these? Okay, so let's say this column will act as a vector and this will act as a vector, but what about this index? Okay, so I will say that I will extend this vector to this position and I will name it as column 0, let's say, which will keep the track of the zeros in the first column. Okay, now it might become easy now because we have saved the space complexity, but see how. Okay, and I will initialize this column 0 with 1, right? Okay, so let's first see what will be the output of this test case. So let's say if this is a 0, then this complete column and this row should be 0. If this is a 0, this column and this row should be 0. If this is a 0, this column and this row should be 0. It means in the output only this one will be left and all the rest of the elements will going to be 0. Okay, keep this output in mind because we will need to verify some edge cases in this approach. Okay, so let's see. Now let's start iterating in this matrix. Okay, if this is a 1, okay, go ahead. If this is a 1, okay, this one, this one, this one, okay. Now this is a 0, so what I will do, I will mark it as 0, mark it as 0. Okay, this one, okay, 1, 1, 1. Now again I got a 0, so I will mark it as 0 and this one as 0. Now again 1, now again I got a 0, so I will mark this element itself as 0 and this element as 0, right? Okay, now 1, 1, 1. Okay, now we have marked the first row and first column as zeros wherever required. Okay, now what we will do, we will check for first element. Okay, now I will check whether column 0 is a 0. Yes, so what it will do, it will update this element to 0, right? Okay, now I will check for this element, it's already 0, it's already 0. Now I will check for this element whether this row of 0 is equals to 0. Yes, then it will mark this element as 0. Oh, what happened? In the output vector we have seen that only this element was 1 and the rest of the elements should be 0. But here what we are seeing that this element is also getting marked as 0. Okay, so let's see what's going wrong here. So if these are the vectors from which we are tracking that whether we need to mark an element as 0 or not, then we can't update these vectors at first. We will update them in the end because this 0 is updating this one and then if this gets 0, then this will get 0. So this is creating problem. So what we will do, we will keep this 0th row and 0th column for now as it is, and we will start marking from the first row and the first column. Okay, so let's see. If this is a 0, let it be 1. Okay, is this a 0? Oh, it is a 0. So let's mark it as 0. This one, yeah, this is a 0, mark it as 0. 1, this is, both are zeros, mark it as 0. 0, this one, this is a 0, mark it as 0. This one, mark it as 0 because these are zeros. 1, mark it as zeros as this is 0. 1, mark it as zeros as this is 0. Okay, now what our output became? Our output has become till now this 1 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0. Okay, and this 0. Okay, now we need to update our first row and first column as well. Okay, so what we can do, can we still update our first column with the help of this column 0? Let's say if it is a 0, then we will mark it as 0 and rest of the elements as 0. Okay, now on the basis of this element we will mark these elements. Okay, now again it will become 0. Oh, what happened again? Okay, so you can see that these elements are dependent on this element, right? And these elements are dependent on this element, right? So we can't update this element at first because these elements are dependent on this element. So what we will do, we will first update this first row according to this first element. If this is 1, then we will not mark these elements as 0. And then we will update this column, this first column, according to these elements. This is 0, okay, mark it as 0. Now complete column as 0. Okay, so what you have seen in this test case is that this first row was having dependency on this first element. That's why we can't update this first element at first. We will have to update this first row and then we can update this first column according to this variable. Okay, so see, in our final output we have got all the elements as 0 excepting this corner element. Okay, so what will be the code for this? Let's see. So what we are doing, we are creating a column 0 variable and it started iterating in our matrix. And if it is a 0, then we will simply mark the element in the first column as 0 and in the first row as 0. If j is not equals to 0, if j is equals to 0, then we will simply mark the column 0 as 0. Okay, now we will start updating our matrix from first row and the first column. If either the element in the column or the row is 0, then we will simply update it to 0. And now we will check based on the first element. First we will update the row 0 and then based on the column 0 element we will update the column 0, yani 0th column, right? Okay, so let's see what will be the time complexity for this. So its time complexity will be n cross m for this, n cross m for this. So its time complexity will be big O of 2 into n cross m and somewhere n plus m for this. So its overall time complexity will be n cross m. And as we have not used any extra space, so its space complexity will be big O of 1. So see, in the optimal approach, we have reduced our space complexity to big O of 1. So yeah, that's it for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.